Hello, everyone. I guess we're live. Welcome to our very first workshop for Canton Construct Ideathon, live here in this Zoom link where everyone can join. This is open for your friends, teammates, co-participants to join in. Just share the link to your colleagues, all right? So, as we wait for a number of people to join our session today, let me just introduce myself quickly. I'm Charlene of Angel Hack, the organizing team of Canton Core Academy, and we're now at the phase two of the program, which we call Canton Construct Ideathon. This ideathon runs until December 5. Right? Okay, so we are aware that we are joined with developers globally. And so let me greet you with a good morning, good afternoon, and good evening. Okay, now I'm just gonna wait for some more participants to join. So if you have any teammates that wanted to hear about this session, please let them join and then share the link to them. Oh, hello. Nice. Would you want to type in which country you're dialing in from? I'm from Singapore. I mean, all of us are from Singapore. Oh, Nigeria. Hi. Great, great. Indonesia. Nice. Kyrgyzstan. Oh my goodness, that's great. Hong Kong. Wow. Interesting. I believe that for some of us, it's morning, it's afternoon, and it's evening. So hopefully all of you are having a great day or a great night. Okay, so I just want to give you a warm welcome with our first workshop of Canton Construct IDFM once again. So today's workshop is about basics of AMMs and DEXes. So automated market makers, AMMs, power decentralized exchanges or DEXes by enabling users to trade directly from liquidity pools instead of using centralized order books. This topic covers introduction to automated market makers or AMMs, introduction to decentralized exchanges or DEX, plus the introduction to Cairo. And also, I just want to give you a quick note that for the Q&A, definitely some of you might have questions and we do expect questions from you. So during this or after the workshop, please feel free to drop in the webinar chat where you're all chatting now and we'll share the answers on Discord afterwards. So please make sure that you are on Canton Core Academy Discord. Okay, let me see. All right, I think I'm going to introduce our speakers right now. So for today from Angel Hack, we have two gentlemen who will be leading our workshop. Let's welcome Kenneth of Angel Hack, Head of Product, and Irene, Angel Hack's Technical Product Manager. I'm very excited to hear from them, and I hope you're all excited as I am. So let's go and learn. Kenneth and Irene, take it away.
Sure. Very good morning, good evening, good afternoon, everyone here with us. So I think in today's workshop, what Shannon has covered, we're going through what AMM is about, how swaps are conducted on DEXs, and what exactly is a DEX, along with, I guess, how you'll be looking to build on Canton Network since you're part of this Canton Construct shop. So just a quick background, Angel is a global innovation platform, community builder with over 300 developers. So we pretty much lead and spearhead innovations through hackathons, incubators, and building of digital products. All right, jumping very quickly for the agenda today. So we'll be first covering the introduction to automated market makers AMMs, what makes up the AMM, the key components of it, types of it, and how you can go about building an AMM on Canton Network. Subsequently, we then cover decentralized exchanges, DEXs, what is a DEX, type DEXs that that exist in Web3, how swaps work, and also the key considerations for building back a DEX on Canton Network. And we will also showcase actually Angel Hack's own DEX that is built on Canton Network called Cairo. So give you a better understanding of how we actually built our own RQ DEX and give you some examples of key considerations that we need to cover. Right. So to kick off, we'll be going through the start of the introduction to AMMs. So I think for those who are not familiar to AMMs, DEXs, etc., not for the Web3 space, you might be wondering what exactly this is about, what AMM is about. So basically AMM is like the key essential building block for decentralized finance or DeFi. And it's essentially the backbone of what powers decentralized exchanges. So you can think about it like like a robot on chain that actually just helps facilitate swaps and transactions, basically calculating prices and then giving you the output for whatever input that you want to swap. All right, so what exactly do AMMs offer? Well, so AMMs exist, I said, to support like the operation of DEXes and swaps. So basically, it kind of enables decentralization in the form of, let's say, Irvin, myself, want to make a transaction. We do not need any middleman to actually facilitate a swap between, let's say I'm swapping ETH for USDC, for Irvin's USDC. I don't need anyone to actually facilitate this transaction. I can just happen on chain through an AMM. And of course, as you know, in Web3, we operate 24/7. So liquidity, 24/7 liquidity is actually enabled through AMMs. And yeah, the other, I guess, benefits of AMMs we could look at is liquidity pools where users such as anyone on chain providing, say, ETH/USDC LP can actually earn fees from all the trading that's happening on the LP itself. And finally, given that, it's a decentralized concept, sorry, decentralized protocol, you actually retain full ownership of your own funds and everything's executed on smart contract. So there's basically, yeah, no risk for any middleman coming in to take over your funds, etc. But of course, it's not perfect because actually you actually encounter things such as like implement loss, where if a price moves too much in one token, you end up holding another token. Sorry, if price moves for one token and the other token doesn't have a corresponding price increase, you end up encountering this thing called impairment loss, where you pretty much have lesser money than if you were to held one side of the token there. Then there are other risks such as MEV, maximal extractor value, where basically since all your swaps are actually publicly visible, uh, trade execution such as like front running can happen, and this essentially causes either your swap to give you a lower than expected output. Then there's also things like loss versus rebalancing. So basically, there's an arbitrage opportunity on chain where the price quote on a DEX is somewhat higher, somewhat either higher or higher than I guess a price on SEX on a centralized exchange. People can then come in to then arbitrage this price and then basically impact the LP. So yeah, uh, basically then to summarize some kind of use cases of AMMs, they pretty much enable swaps transactions to happen on chain. You can also do things like set up of low slippage liquidity pools to do stablecoin trading. Oh, sorry, swaps. And then, like I said, you can also utilize idle assets for yield generation, and of course, open new liquidity pools for tokens, long-term assets such as like in coins or new tokens that have just launched. Okay, now I'll just quickly go through the key, I guess, what makes up an AMM. So the very as heart of an AMM is actually we operating through something called a liquidity pool. So basically, a liquidity pool is just a pairing of one token with another. So the example here is basically ETH and USDC, where the user then deposits it, for very simple example, and so sorry, for example, we just deposit equal amounts of like USDC and ETH, and then this pool will then be available for anyone who wants to swap either ETH or USDC. And then this falls on a pricing mechanism formula, basically a basic math formula, where X multiplied by Y equals K. So as more tokens go into the pool actually rebalances and then gives you output. Yeah, so and prices will then adjust dynamically based on the amount of input and output that goes through. Okay, so based on that pricing formula is when you execute a user execute swap, this is actually how the price changes. And yeah, for the liquidity provision part of things, generally if there's an LP pair, the user or the LP provider actually gets LP tokens representing the share of the total liquidity pool, and they also earn a percentage of the fees from trades that are being made on this specific LP. So except there is of course the risk of impermanent loss. So if a specific one side of the token pair actually so-called wounds, you might actually incur impairment loss if the other side of the token pair doesn't actually correspondingly adjust in price. So it's impermanent because actually, as price fluctuates, it may actually go back down to the original levels at which you input the LP. So yeah, then of course, in terms of AMM, there are actually advanced kind of models that exist in the space. So it's not just basic X times Y equals to K formula. There are other things like multi-asset pools, such as the balance of protocol, which is a weighted average function. And of course, you have advanced mechanisms such as concentrated liquidity, dynamic liquidity. And generally, these models also feature uh, tiered fees as well as kind of like rewards incentives to incentivize users to then provide LP and then earn rewards. Okay, so I won't talk too much to this because it's pretty much just a key summary of what the more popular types of AMMs in the market. So the basic, I think what most people know is Uniswap is the constant market maker CPMM. Then we have a hybrid constant sum market maker, which is generally used to provide kind of stable point swap. So like something that we see in finance. And then there's of course the concentrated liquidity market maker. So just the more advanced type of market maker AMM, which normally you see in the use of B3 contracts as well as Trader Joe protocol. And finally, what I just mentioned, the constant mean market maker. So one essentially allows users to kind of pull together assets, more than two assets actually, to create their own liquidity pool. Yeah, so generally, key things that you want to look into when you are actually looking into AMM space would be the underlying formula. What's the capital efficiency? Is there any risk of impermanent loss? And kind of how would you be utilizing this specific AMM type? And actually, this is just some examples. So there are, like I said, there are actually much, much more, such as like DLMM, etc., that exist in space. So I think on to the part where I think should be most relevant for the builders here, which is when building an AMM protocol on Canton network, what do you need to look into? Okay, so like I said previously, for example, if you're like on Uniswap and ETH, right, all your LP states are publicly visible. So because every node requires is needed to validate the trade that's executed. So any financial institutions that are actually executing trade on, say, ETH mainnet can technically trade with intent. I mean, you cannot basically shield or like right add a privacy component to the swap that you're executing. So for Canton, this is a little bit different because every state is partitioned, which means assets that are going through being traded on network actually quote unquote live on different summits. So if I could to give you an example, basically what this means is that if I'm trading ETH from say a bank A, and USDC from bank B, that exists in two different substates or validating nodes. So there is no single space where this transaction is like publicly visible to anyone that can see how much the quantum of ETH or USDC being swapped or received. And this is actually what Canton Network was being built for, which is the purpose-based permission public network. So yeah, the summarize kind of the Canton Network difference enables kind of institutional AMMs to be built where let's see the architecture and where you can actually customize different liquidity pools to exist based on the different needs of the clients, users, or traders on Canton Network. So all this is actually accessible and enabled by what's called the global synchronizer. So what GS is basically the backbone of Canton's interoperability. So it's kind of like the main orchestrator facilitator for any transaction flow on chain. Then if you're building an AMM, you need to ensure that uh you understand how a transaction is facilitated on chain because everything is settled atomically. So basically, when you place a trade, as a user, you place a trade, uh, the swap is settled atomically between it either happens or it fails. There's no in between where there is a half transacted state, etc. And why this is important is because you basically need to construct the AMM such that uh, the different execution flows that you kind of code in the demo contract allows for such automaticity to happen. And subsequently, you can also actually combine what Canton networks kind of like underlying technical infrastructure with additional layers of smart contracts to actually allow atomic cross-chain transactions. So if you're familiar with like bridging, that concept of bridging from one chain to another, you can actually do atomic cross-chain swap easily with when building AMM on Canton network. And finally, yeah, the difference between what building Canton versus other EVM SVM chains is basically you can actually retain the privacy of the contents of the swap. So in terms of like the quantum, the type, the asset class, and the party, basically the addresses, etc. All these can be toggled on and off in a state which is permission, and you can actually select who are the users or the viewers. So to summarize, kind of when building on Canton network, you're building for a regulated kind of privacy first network on the on demo where basically you can layer on top basic specific enterprise features like states where you can actually for example like for trade financing or such use cases you actually can approve specific swap transactions occurring at different stages of the trade finance flow and also enable kind of like on-off toggle features for who are the participants in this swap contract or and the quantum that's being received and the type of asset classes being swapped. Yeah, so essentially, kind of if you're looking to kickstart, kind of, I guess, building an AMM like protocol on get the network in demo, then what you need to do is basically define kind of a template for the pool contracts. You're going to involve who are the key parties, kind of the key execution decisions for any deposits of assets if you're doing like an escrow or swap, and of course, kind of the mathematical formulas enabling the AMM. And yeah, you pretty much need to also take into account kind of edge cases like how to manage liquidity and price impacts if you're using a mathematical formula for your AMM. So kind of quickly summarizing the first part of AMMs on Canton network. I think what you guys could probably be looking to build out is the AMM protocol or feature with privacy and atomic composability. Right. Quickly move on to the next part, which is the introduction to DEXes or decentralized exchanges. So DEXes are essentially platforms that are built with blockchain tech that allows users to then, of course, trade digital assets such as ETH, USDC with directly on chain. So this happens without any banks or intermediaries like what you normally see on centralized exchanges like Coinbase, Binance. And as a user, you basically hold full control and custody of your funds when you're executing a swap or transaction on the DEX. So apologies, it's a minor typo. But what DEXs technically offer is really decentralization, where there is no man involved. You can actually execute trades on chain any given time. So the market okay, so DEXs actually has no operating hours, kind of like the stock exchange. And of course, this tied back to the AMM. So assets that are idle, you can actually deposit in an liquidity pool, and then the liquidity pool tokens would then be enabling a specific software on the DEX. Right. Then kind of go into quick use cases of what DEX is enable, which essentially uh basically allowing you to kind of do basic swaps with tokens that are on chain course, enabling trades. Sorry, there's a minor error this side. But yeah, maybe I'll skip this use case. I can just give you a general summary of like use a DEX. So your DEX basically exists on chain to like to facilitate a swap transaction where if you want to receive, say, like Canton coin, and also your Canton coin for like a CBDC, it allows you to do so. So it's just a platform that allows you to then transact on chain, swap the tokenized assets that you want. And of course, depending on the type of DEX, you are able to customize the swap or transaction execution flow. And kind of give you some examples of like kind of popular DEXs that you can just quickly take a look at and reference in your build. So we have like Uniswap, DEX aggregator, like Llama Swap, DeFi Llama Swap, Meta DEX aggregator, then Grid Finance, as well as the kind of more popular ones like Hyperliquid, which is an order book based per DEX. Okay, coming to the underlying swap execution or facilitation on the DEX. So how the swap normally goes is that there is a approval stage where the user first signs a transaction that allows the DEX smart contract to then spend the token that they are trying to swap out. Then execution and then happens subsequently. So the approval stage where you sign generally triggers the approval and subsequently you need to sign a execution transaction swap. And the contract then, of course, takes in the calculated exchange rate based on the current liquidity pool status, and then swaps for you. So then the token transfer happens from the LP. So, sorry, yeah, from the LP, basically where you take the token from the user, sends to the LP sends back the target token that you want to swap out. And then generally the liquidity pool is then updated automatically, and then the price adjusts automatically. And in summary, a swap is basically something that's facilitated by a DEX through atomic smart contract interactions. Yeah. All right. So this is a example of how the whole swap execution flow is done on a diagrammatic basis. So user connects your wallet to the application, and then as a user on swap state, for USDC, I request a swap transaction where I then need to sign. This then triggers a smart contract uh on the DEX, which then executes the swap, which interacts with the AMM smart contract holding the liquidity pool of tokens. And then, of course, you then execute the swap transaction, then conversely, everything is, of course, shown on chain, like what the price is going to receive, what's the target output. And then when swaps finally transacted, reserves are updated on the LP smart contract, and token balances are also updated on the ledger. So they reads the updated user balances, and when the user receives the swap tokens, sorry, that they swap. Essentially, this is just the general flow of the swap for AMM DEX. And then you also have the on-chain order book DEX swap flow, which is slightly different because the order book has different, I guess, multiple levels to it. So the start is the same kind of wallet. The activation, you actually submit order. It brings the order book state to then return all the different values for the big ask spread. You need to then validate whether the order can be executed as a limit order, market order. Then it then updates the order book state, runs the matching orders, and executes. And settlement side of things is pretty much similar to the above. You basically it just updates the token balances once the swap is executed on chain. I think user then just reads the current balance that they receive. Okay, sorry. Okay, so the various types of DEXs on chain basically broke down the few types. One is RFQ DEX, where pretty much you see professional market makers stepping into like sects like off-chain inventory provide kind of means of trading. Then you also have your standard automated market maker like Uniswap. So basically, retail users, any general user can deposit the LP token in a smart contract pool and then allow for swaps that occur. The next one would be CLOP or central limit order book DEXes, where basically it's like maker taker kind of like concept where bid-ask spreads are the means of execution for the trade. And finally, you have a hybrid DEX where you have both AMM pools and of course the kind of like RFQ limit quote or limit orders facilitating swap execution. So I won't go into the general too deeply into all these, but generally when you're looking at the DEXs or looking to build out the DEX, you should be kind of like confirming what is the type of liquidity source that you are going to consider, what the pricing mechanisms in place. Are you going to be basically managing slippage, or how will slippage be, optimized for each sort of transaction? Then, as I said in the AMM part previously, how are you going to protect against math attacks? And finally, who are your target users? And yeah, generally privacy concerns is pretty much is going to be front running. Is there any considerations of like, order book attacks, for example, the CLB stance, and how can you pretty much shield or route transactions to ensure that, these are not something that you see on on the public network. Right, so we come to the next part on so if you consider build a DEX with a on the Canton network, kind of like you do need to consider, is it still going to be deployed with an AMM underlying AMM uh backbone, or are you going to do something different like an RFQ sort of deployment? Then of course that again makes it, if you're what type of DEX will you be, RFQ DEX, a CLB DEX, etc. Then for design considerations, basically it's computing tender network is different from SVM EVM chains. So you need to understand the concepts of UTXO compliance as well as the asset types and atomic composability. So for these three parts, I'm just going to dive into them. So on Canton network, just for context, a holding is also otherwise known as a unspent transaction output or UTXO. So this amount of tokens that is owned by a specific party on chain. So unlike the general account-based models on chains, where balances are stored in single account, Canton uses a UTXO model. So every holding is a so-called separate contract on the ledger with a unique CID, and each holding can specify amount of tokens. The holdings can be locked and unlocked, which is pretty new, unique concept on Canton network. And of course, your holdings are immutable. So I think one main issue, especially when we enjoy building on Canton network, we encounter, which you probably will encounter if you're building a text, is the concurrency challenge, where how would you allow 1,000 users to hit a specific liquidity pool if you're building a AMM type of text, and then how can they consume the same contract at once? Because generally everything happens atomically. You cannot wait for, say, user A to swap, then user B, Q, C, D, etc. to swap halfway, then one execute follows, then the next goes down like a cascade. Generally happens atomically, so you have to swap, execute, and settle all at once. So yeah, generally the main point that you probably face is this currency challenge. And yeah, if you actually encounter this on your hackathon journey, yeah, feel free to just reach out to us on Discord. And then I think next would be the compliance and sets design considerations. So I think take note of is that assets are generally programmable in the demo finance library. So generally they aren't really just numbers per se. There are also underlying metadata they can assign to it, say specific RW token, like what exactly is the token, uh about. Is it pegged to a specific index, ETF, bond, tokenized, like a bond, or and what's the underlying deal? So different asset aspects to assets that are on chain in Canton. And then of course there are embedded controls for compliance purposes. So specific assets can only be held by specific parties that are either authorized through means of a uh like a commercial contract, or you can actually then you need to assign specific values to the identity attribute, like a user from what protocol can access this token, or a user from bank or organization can hold this token. So I think another thing you take note of is the operator role, where there generally a party that manages your pool infrastructure. So that generally operator will generally be the of the DEX. Yeah, which you need to run a validator node to run your DEX application on. And then finally, yeah, so basically that's the challenge that you probably might need to solve is the asset ownership challenge. So if you're building a DEX and basically looking to expand the number of available trading pairs, you need to actually consider how you would approve specific users to swap assets that require licenses, and is there a means to which you can actually blanket whitelist or blacklist, and yeah, how would you toggle this authorization approvals? All right. So lastly is document composability part, where like I said, any on-chain execution on Canton network is settled atomically. So it happens or it doesn't. I think in the basically the key challenge to solve, again reiterating, is the concurrency challenge. How do you allow for multiple users to actually execute a trade on a specific one pool like smart contract? And if it's this if like multiple users try to consume the same contract all at once, it will likely fail. So there are means and ways to actually go about this, which we will probably cover sometime later on when we share what Cairo is doing, our text that we built out has done to actually overcome this. Okay, besides the design considerations, you also need to actually look into the technical side of things. So, say for demo contracts are immutable, and then you have to actually go through a whole series of creating, archiving, and then consuming in the whole execution flow. And I think in that whole process of it, there you might encounter specific times where if there's a very high, I guess, throughput of transactions happening in a specific swap, which generally happens on Texas. How do you avoid unnecessary UTXO proliferation on chain? So basically, I think that's something they need to consider. Then it's aside from this, for price discovery side of things, because I said before that privacy is kind of key on Canton Network. If a specific pool state is private, how would users be able to actually know a price of I guess, a LP pair? So this is something that you need to consider when allowing the view or there's read-only copies of price data on chain and allow that to be properly displayed on the front-end UI. And lastly is the identity management side of things. So basically, you need to have onboard basically users to be onboarded specifically on the node to interact with the DEX. So if when you're creating a DEX, you do need to look into how you would enable, I guess, existing wallets on chain to actually interact with your DEX, or you could also look into building out a standalone wallet just for your DEX itself through the wallet SDK that's provided in the demo Kickstart documents. Yeah, but essentially it's not what they are. If you're familiar with Web3 wallets, how they call it, your Metabase or Webby wallet, it's not as simple as just clicking connect wallet to the application. So I guess that's something that you might need to take note of. And yeah, as you build out your DEX, and of course consider the AMM specific underlying infrastructure to support the DEX or DEX operations execution, you will need to, basically think of how to redefine non-custodial trading on Canton network. And pretty much if from like a trade fi background, something like trade financing through a deck, execution trade financing through a DEX might be something you could look into, or I guess constructing a DEX that is shielded with dark pools would be pretty interesting since privacy is, let's say, uh, a key factor on how Canton network operates. Yeah, but I can pretty much come to the end of my part, and I'll pretty much hand over my time to Erwin, who will bring you through the decks that we built.
Yep. So we'll be introducing Cairo next up. Yes. So Cairo is a DEX that is built on Canton network powered by Demo smart contract, or for Demo we call it workflow instead. And so Cairo offers a RFQ based swaps for all native digital asset that exists on Canton network. And so what do we provide value is that we provide the unified trading experience, meaning to say we can swap like multiple tokens in just one platforms rather than you have to go to different exchange for like different set of tokens. And we provide atomic security. And so that's one of the key features of Canton network is that everything is settled atomically. And so it's either the transaction passed or the transaction didn't happen at all. So that's the key unique of Canton. And we also provide advanced flexibility and integration for different liquidity providers because we can easily swap out the LPs and different sets of tokens. Next. Yeah, and so this is a comparison between like traditional AMMs and DEXes in other networks, like say for example EVMs, SVMs, and so forth, versus like Kairos, which is permission and public. And so in a sense, it's public because anyone can join the network. You don't really require uh, uh, like a node. You just have to connect to somebody and then they will do like their KYC and then you can connect to the network. And so traditional like execution models for like the DEXes would be for your other networks like AMMs and public order books, which is your which we also covered just now. But for Cairo, it's mostly just RFQ because this network it's private. Yep. Uh Yeah, and some of the requirements for Cairo is that it requires you to use specific templates, like your splice utilities or utilities template, so that it can be integrated to your network or to anybody's network. But for AMMs or like traditional like Solidity or Rust, you can use like any uh, a smart contract or like your own customized functions. Yeah, that's pretty much the more or less of what's the difference. Next slide, please. And so this is how the workflow of what Cairo does. So usually the flow of it goes is that user connects the wallet to Cairo and then it creates the swaps. So the RFQ engine or the logic is off chain and it calls the API of the demo workflow. So this and then you request the quotations to LPs. And so the unique thing about Cairo or this workflow is that the asset balances are on chain, whereas the quotes and the pricing is off chain. So usually it's done by the LP people who will give you like a best quotation price or fixed price, and then it depends whether the user wants to accept the offer. And so if the user signs the transaction, this will call the settlement workflow, which is your demo transaction, and it executes the swap atomically by calling to the LP and updating the balance of the wallets. And so this is only recorded in the Canton ledger, where your it's only the successful transaction that is recorded. There's no like failed record. So say for example, if the user were to cancel this transaction, none of these would be recorded in the ledger at all. And so usually how do we save costs from like reading the ledger because it's expensive is that we stream these like events and update our projections of like the user balance, and then from there we can display it on Cairo. And so the key things to take note are that some like the non-consuming UTXO of the request swap and the request quotation. But once the the settlement workflow executes, it would consume as many uh, uh, like different balances, I would say, and combine them or like split them to however much you need. So say for example, if I have a balance of 10 CBDC or 10 CCs, right, and I want to swap for one CBDC, for example, let's say my 10 CC is I have let's say 20 in my user wallet. So this would split it into 10 and 10, and then it would do the execution. And likewise, if let's say if my wallet has like five balance in a contract and another five balance in another contract, the UTXO would combine these both into 10 and it will execute the swap. Yeah. So that's a key thing to take note. Next, please. Yeah. So yes, just summarizing it, our tokens, our DEX is RFQ by design. So traders can select the token pairs that they are looking to swap, and a code would be generated for them through the workflow we show you just now, and the execution is atomic. Yep. Next, please. Cool. Yeah. So we do provide open source repo for tokenizing an asset. And so if you want, you can take a look at how our asset is being tokenized, and then you can use this like tokenized asset to execute your swaps and build your own DEXes. So yeah, very excited to see new projects, and I think the next is Q&A, right? Yep. Cool. Task.
All right. I
Cool.
think that's it. What an amazing session. Thank you so much both for doing this. So this is such an insightful sharing and well-organized workshop. So I'm sure everyone not only enjoyed it, but also learned a lot from it. So if you have any questions as flash on our screen, feel free to drop them in the chat. We'll post the answers on Discord within the next 48 hours. So what we have covered today quickly are the basics of AMMs. We learned the key formula, capital efficiency, risk of permanent loss, DEX, type of DEX, etc. Then the introduction of Cairo. So these are the topics that are really essential for us to succeed in this hackathon or this ideathon. So please digest it, okay? So once again, for any questions, please feel free to leave a question in the chat and we'll be answering it and posting it on Discord in the next 48 hours. I can see that we have a lot of interesting and wonderful questions on the chat already, and rest assured that this will be addressed on Discord. And well, if you're still digesting what you've learned today and your question might come later, please message us on Discord under Mentors Assistance and we'll address your questions from there. Okay, I believe that the Discord link has already been shared. Thank you so much. All right. And lastly, we'll be having our second workshop on Thursday, 27th of November, 10 a.m. Eastern Time, about lending, borrowing, and yield applications live with our speaker from TradeWeb, one of the Canton Network's ecosystem partners. Please always tune in for the announcement on Discord, X, and or if you're subscribed to our emailing list. And hope you had a wonderful and fruitful session. I just wanted to check if Kenneth and Irvin have messages before I let you go. Okay.
Yeah. No.
All right.
Excited to see what kind of products they are building.
Yeah.
We're all excited to
Likewise.
see that. Yes. December 5 is our deadline, okay? Code faster, but code with efficiency and quality. All right. Okay, hope you had a wonderful and fruitful session with us, and we will see you once again on November 27th. Thank you, everyone, for your time. Don't forget to give us your questions in this chat or on Discord. Then we have the link on Discord that has been shared already. Please join the Discord channel. All right. Have a good morning, good evening, good night, everyone. Thank you.
Thank you.